Thanks for having me. As you already saw in my notes for this slide, since you read those, I don't need to tell you this part. My company's Anaka. We're about 25, a little over 25 people, most of which are in South America. I actually live in Argentina right now. I was inspired to go into the past to move to Argentina by Luke's talk a few minutes ago. I've been there for like 5 years. I'm actually kind of relocating back to the States, but and keeping my team down there. So basically, like anyway, one thing I want to say is thanks to you guys for organizing the conference. It's really great. So Kevin Smith was supposed to talk, and then he couldn't make it, so I kind of took his slot. So I'm sad he's not here. He's kind of a friend of mine, but anyway, glad that I could take the time to talk. So really quickly, we basically are a team of guys who like interesting languages. We do a lot of iOS apps, Android apps, and then most of the time we back those with Erlang on the back end, some Rails as well. We're a pretty polyglot set of developers. The one thing that's a little bit different is we pretty much take projects we like because we almost always host them long term. So we really like to do what we call remote bootstrapping. So we'll build a product, we'll help launch it, and we'll kind of run it long term. So mostly for funded startups and then some media companies as well. We kind of get this random niche of like what they call second screen apps. So second screen apps are basically like apps that are designed for watching TV and then chatting with your friends while you're doing that. So we've done some for Viacom and a couple other companies, Fox. And then but I'm going to focus on one today called Whisper. So Whisper is like kind of a really interesting app. It's growing extremely fast. It's essentially a top 10 social media app and one of the biggest apps in the App Store right now, or fastest growing. Time is running here, sorry. Anyway, all right. So what is Whisper? This is a good example. Whisper is sort of like Pinterest plus Twitter in the sense it's got, I would call it like a pseudo-anonymous social network. You can talk about subjects that you probably don't want to talk about on Facebook or Twitter. It's very visual like Pinterest, but then it's character limited like Twitter. So it's the easiest way is just to kind of look at a few. I picked these randomly today. There's a ton, and so and these are like the topics range from sort of super safe to pretty interesting secret to like relatively not safe for work. Which we'll talk about actually quite a bit. So to keep you guys awake. So basically, as I wrote the talk, though, I really wanted to sort of like carry on the theme. So I have some of my own secrets in here that you guys can read. But we launched it back in April, and it's grown like basically quite quickly. It's a pretty high time on site, like it's very, very high usage pattern. They didn't want me to talk about specific numbers, but it's really, really just to understand the scale. I mean, like it's like if it were a website, it would be definitely one of the biggest websites out there. It's kind of crazy. Just like hundreds of millions of high hundreds of millions of page views. So basically, so I'll give you my first secret. My first secret is I'm a chronic premature optimizer. So the way I would describe that is, I like to over-optimize and overscale like way before I need it. It's happened to me a million times with so many projects I've built. It's like a constant problem. And I think as you in your career you start to learn the things that you do over and over as a developer. That's one of my problems for sure. Like somebody says they want a system, and I'm like, oh, I have these moving parts, and I've learned sort of like that quote about like I wrote you a letter, I didn't have time to write a shorter one, right? And so often there's that sense of like, if you have the time to take, you can actually realize you can sort of like simplify your architecture. So I'm going to talk about some of those mistakes here. I would call this a survivor's bias talk. And I don't know if you guys are familiar with those, where people do talks and it's like, these are all the things I did, and this is why it's great. If you do this, you're going to build a huge app too. That's exactly not what we're going to do here. I'm just going to tell you the mistakes that I made. And in fact, I think we made a lot of the wrong mistakes. So we're going to talk a couple things. Basically, architecture mistakes that we made, this is how we fixed it, the things we like about Erlang, how it's helped us scale, the things that we like about Erlang in terms of how it's helped us to moderate the content, which I mentioned earlier, and then some of our favorite tools. And I'm actually really excited because a couple of the tools that I'm going to talk about very briefly were covered in the lightning talks. So that's kind of cool too. So I can kind of give you guys some real world, like this is why we like those tools. So anyway, I'm going to move pretty quick because there's a lot to cover. I thought I had 45 minutes and I've only got 30. So I'm just going to go fast. And if I get, please stop me if you get stuck and if you're overwhelmed. I'm happy to repeat stuff. So architecture is basically pretty straightforward. At the beginning, we used Erlang, Riak. We used Elasticsearch, which is based on Lucene, which is pretty cool. And then we used MokiWeb. We probably would have used Cowboy, actually, because now we sort of really embraced Cowboy internally at Anaka, but when we built this, we hadn't yet. So, but MokiWeb's great. So we, basically, at this point, we were totally Erlang stack, and we built this whole thing. And we were so into Erlang that we actually put all like our node and the Riak nodes on the same hardware in front of a load balancer, which is kind of cool. We were like, hey, this is great, Erlang, uber alles, this is wonderful. So we launched. So we launched with Riak. Launch was great. I will say one thing, which is like, I was like, let's do Riak, it's going to be cool. And I know I've used a lot of NoSQL databases. We had a lot of MapReduces, and one thing I would say is, at this point now, I recognize if I see that, it's kind of like a sort of a code smell or architecture smell, in the sense that it's like I'm doing so many things in MapReduces and secondary indexes, it might make me kind of realize maybe this isn't the right database for the job. So we first launched, everything's great. We had, every couple of days we'd have like a timeout, and then like it was 4 days, then it was 2 days, then it was like a day, and then and the users are slowly going up. Actually, they started pretty quickly, but then they just sort of slowly went from there, growing. And we were like, I don't know what's going on, what's happening with Riak. And it was pretty clear, not too far in, that basically we had some problems with MapReduces. So we said, okay, let's get rid of all these MapReduces. Let's start to think about how can we architect our schema to basically not have to like surf through the across all these keys in Riak. So things like let's create an extra key for all of the hearts, and then we'll stick all those hearts in here. That way we won't actually have to go and sort of surf across the secondary index, that kind of stuff. So we did that, and we still had timeouts. We still had a lot of problems. So we said, okay, let's get rid of all the secondary indexes. We'll get rid of all those. We'll figure out a way to basically not use those. We build a separate like a database that's just like our own level DB store, and we'll sort of use that as an index, and that way we won't go to Riak if we don't need to. And we still had problems timing out. So effectively, more users and more timeouts, it just kept going. This is really interesting, but basically we couldn't find any problems, and we basically got rid of all the sort of random MapReduces and secondary indexes. And I would like to say one thing that's really great. There's a lot of Basho guys here, and I know a lot of friends at Basho, and actually they're really amazing. Like, their support was amazing. We had not actually paid for enterprise support because things happened so fast we didn't even have the time to do that. And so we were on IRC. I'm talking to Sean Cribbs. I'm talking to guys, probably other people in this room, I don't know, on IRC and on the forums. And basically, we couldn't quite figure it out. So I started using this service called Boundary. Is anybody familiar with Boundary at all? Yeah. So Boundary, ironically, is actually an Erlang and a Riak shop, so they sort of know this stuff well. But effectively, Boundary is just like a visual TCP dump, if you will. So Boundary allows you to run this little app. You run a service on your server, and you run this app. You log in. They dump an unbelievably massive amount of data, I'm sure, to their data store. And it showed these sort of really interesting things. Like you see up here, it's like 800 megabits per second of traffic, and then 0, and then 800, and then 0. Like this sort of really, really bursty. And that's not how our service works. I mean, it's like consistent all day long. So I basically, and you see these little things here. So I ended up like randomly talking to one of the Basho support guys, Sean, and he was like, I think you have TCP Incast, which is a treatable disease, but it's basically a network degradation in sort of specific circumstances. So is anybody familiar with TCP Incast? Yeah, it's kind of, the people that are like, oh yeah, it hurts right here. But basically it requires like servers with a lot of CPU and memory, super fast Ethernet, multiple switches, and then like a certain usage pattern. And literally like that exactly describes Riak, right? So what's interesting is it's connected to switches. So one of the things that I learned was that we were on a provider called Storm on Demand, and I think they're actually pretty good. There's some things I like about them. They're owned by Liquid Web. They're kind of interesting, but what happens is you can sort of pick like their sort of like what would you call it? Hardware that's you can get sort of dedicated hardware, or you can get their sort of, I don't know what it is. I guess it's virtualized, virtualized hardware, and it's obviously these commodity switches that just couldn't handle our traffic. So all of a sudden we get this problem. We've got to get off of this hardware. We've got to migrate, right? Well, the problem is we couldn't get the data out of the cluster. So like things are so bad and they're getting worse so fast, sort of exponentially, that we couldn't even get out of the situation. So we said, okay, what are we going to do? Let's migrate to a different data store. And we're, this. Keep in mind, this is a client. We've worked with them on a couple of different projects. We invested a bit in this company, so we have very close relationships. At the same time, they're a client, and they're sort of freaking out. So we said, okay. To be honest, I've had some rough experiences with Couch, and this got so bad that I was just like, I don't want another NoSQL database ever again. I know MySQL, I'm going to do that. And I now started mildly resenting anyone who chooses NoSQL for whatever reason. But then I realized that that's actually kind of not me taking responsibility. It's like it was my choice. And frankly, I didn't understand the app enough. I just made a bad decision, right? So I sort of said to myself, I will no longer choose NoSQL without first finding my sort of SQL limit. So this is like my new mantra, right? I think if someone comes to me and says, hey, should I use Riak or should I use, I like Riak, I think it's got some really cool stuff. If they say, should I use Couch? I'll say, oh, I'm going to use Couch because it's going to let me scale whenever I have a ton of users. I will refrain from slapping them, but I will say, listen, don't prematurely optimize, right? Just use the right tool, and then you can replace it when you need to. So basically, really quickly, we had to replace everything sort of in flight. We had to rewrite the remaining map reduces and anything that wasn't sort of fanned out as SQL queries. The thing about Erlang is if you're dealing with JSON, you get a lot of prop lists, so we sort of had to say, are we going to create this schema, are we going to make this giant table with JSON in it? And we sort of, said we've got to get off of here, so we created this one table per data type, and we just sort of dumped all the data into this table called data. The bucket with key and value fields. And frankly, it worked. It got us out of this crazy situation, right? So it's like NoSQL on top of SQL. And I thought it was kind of interesting. So over time, that's obviously not going to work, but we migrated to a much better schema. And we use this thing called the Large Hadron migrator, which is hilarious. It's basically, our admin is in Rails. And so our admin is all like, and the web piece, which is a very small part of the app, is in Rails. And we realized, one thing that Rails actually has pretty good if you're using MySQL is migration tools. So we use some of these built-in gems for that, and it worked out really well. But now we're spending all of our time managing MySQL. So that was a problem, but it's predictable, it fit the data better. And this is the thing that I think it's really important that I've learned. I think when you know you need a super powerful NoSQL store, you're going to know because your operations team or your DevOps guys are going to say, hey, we need this, right? If you sort of like push the noodle forward, say, we're going to do this because we think we might need it, what you don't realize at that time is that some of the tools you might need aren't available. So frankly, we just got to a situation where we were losing data and React and all these problems that we didn't really know how to fix because we didn't understand the tools that well. So I might come back to React in the future for a project, but I would make sure that I knew exactly why and I knew how I was going to manage it. And frankly, I would probably never deploy it again myself. I would use like the equivalent of RDS, something where it's hosted, where it's somebody else's problem, right? We basically knew we were going to migrate to Amazon off of Storm on Demand, and we wanted to, we sort of now have this problem because our MySQL servers are growing so fast they can't keep up. So this is my last sort of secret, which was how much time NoSQL will take, according to what's visible, this is how much time it takes. This is not really, I guess my point is, like, I'm actually a huge Erlang fan. I feel like I preach Erlang everywhere. What I realized is that you know, I have to sort of separate out, sort of like using the data store. We're using Erlang. Erlang actually works really well with Postgres and works really well with MySQL and some of these existing database tools. So it's just knowing the right tool for the job. So that's sort of like my cautionary tale. But you know, the real interesting part is sort of like how we dealt with the scale as it kept growing. So basically, this is the architecture that we sort of had. You know, I guess when we moved over to Amazon, you know, double everything. You know, multiple load balancers, multiple MySQLs, a lot of Erlang servers, a lot of Elastic servers, plus admin and web ancillary servers. It's a lot, or a decent amount. It kept growing. The problem with that was we started adding like a database a week, and it was like a read-only that just started getting out of control. So we said, okay, we got to start caching things, right? So there's sort of two types of activity in this app. There's like hotspot of global activity, and I'm gonna see if I can find it here. So like, just to show you the app, it's sort of like, you know, I don't have a network connection here, but you can kind of see there's just like infinite stream of latest. And I would liken it to like imagine if you had Twitter and Twitter had one global feed and everybody was subscribed to that feed, right? That would be amazing if you were the Twitter engineering team, because you would just be like, great, we'll stick it in memory, no problems, right? And then there's this sort of popular, which is like all the things that sort of get popular over time. And then there's this nearby tab, which I don't know if that's going to work. But basically the nearby tab is sort of like what's happening right around me right now. And I'm sure that's not here because the simulator simulates that you're in Cupertino. So anyway, basically you've got these two types of activity, global and local. So, you know, popular and latest are actually quite easy. This is one of the things that makes Erlang amazing. I don't know, it seems like a lot of people here have not done Erlang coding sort of in anger, if you will. Who has created a Gen server in here before? Like a lot of people, not, I guess after today, maybe a lot more. Okay, so the great thing about it is you can just literally create a Gen server, store that stuff in there, and it kind of works, you know? You actually can, you know, sort of just keep it in memory. It's not that much data. Memory's cheap, and you know, it's great. So that sort of covers the popular and the latest. That's just like one Gen server, super simple. Now, the problem is you actually, when you have like, you know, 10 servers and maybe more, and you know, it's going to be, it's like another one every few days, it feels like. So you got to figure out a way to sort of move that data across all the servers. So you want to start caching all the other things too, the users, the hearts, the replies, all that kind of stuff. And for that, we're using this really cool thing that it was built by an Erlang guy, electronic arts, like LRU cache. So this LRU cache is essentially local, and it does a broadcast to other nodes. So essentially, like, takes all the data that comes in. So if somebody comes in and says, I like this thing on one server, you know, that little LRU cache can broadcast to the other nodes. So we use PG2. I don't know if somebody mentioned PG2 today at all. It's essentially, you know, it's kind of cool. It's basically like this process group. So process group just says, hey, I've got a process. I want to register as belonging to this group. I belong to that group, and I can say, okay, now I can send messages to that group. I can find the members of that group. And so we can do something really cool. So we basically say, okay, create this new LRU list or LRU structure. Store, you know, tell it how big we want it to be. Create a cache group. Join that group with ourselves. In other words, I can create a group and I could not join it. Join myself and then store my cache. Now what happens is, messages come in. They say, hey, you know, I've got an update cache message. It's from myself, just to keep track of who sent it to me. And then here's the data. Okay, so this might be like a heart or something. Then I can go grab all the nodes. So I go and I grab like the list of all the servers that have this cache group. And I basically then do a list combination and say, okay, for all the processes, send that message above for P, which is P is like, you know, for P and all list of nodes, go send this message, but don't send it to myself. So essentially, like with this one little line of code, I can basically say, hey, broadcast everybody, but don't send it back to myself because I already had this piece of data. So literally writing this incredibly cool, scales to like 20, 30, 40 servers is like 3 lines of code. It's amazing. So I wrote this the first time and it worked the first time. I was pair programming with a buddy of mine like 6 or 8 months ago, and we were just so excited that you get this to work, right? It was just amazing. So that's the kind of thing where you're like, wow, Erlang is really, really cool. So just as like sort of a visual example, you know, the heart comes in, it gets stored back in the background of the database, but then it gets broadcast via each of these nodes. Any questions so far? Sorry, I'm going so fast.
You mentioned this LRU cache with distribution. You're the one who added the distribution on?
Yeah, so the LRU cache is just like an in-memory data structure.
Right.
And the funny thing about Erlang, this is one thing that kind of sucks about it in some ways, is like it's not very good for those kind of data structures because you can't, the memory isn't mutable, right? So like you've got to, if I have an LRU cache and I want to like read something from it or write something from it, I might need to expire something. Well, instead of just expiring that one item, what happens is you get back a whole new version of that thing every time, right? So that's a good example where we're kind of trading the sort of beauty of how easy it is to build with maybe the fact that it's probably not the most optimal thing to be creating a new copy of this data structure every time, right? But it's really powerful. So
isn't that LRU thing just a list, and you just put things on the end and take them off the other end?
Yeah, there's some rules about how you expire things. You could use that, but the lookups are slow. So we wanted it to be like a faster lookup. Yeah.
Are there any tools for working with relational databases in Erlang?
Yeah, sort of. I mean, it's really funny actually. If I had a network connection, I could show you. But for instance, like because Erlang is really good at protocols, there are like 5 MySQL drivers for Erlang where everybody went and wrote their own because it's so easy, just like, oh, go get the spec for the MySQL protocol and just go write it, right? So people sort of rallied around a couple of them. You guys are laughing like you've been through that before? No, okay. I'm taking notes like who's talking, right? No, basically, you can sort of write your own. So people rallied around a couple. I would say they're pretty good, like pretty well tested. Like the Postgres drivers are quite good too. So the actual drivers are good. The tools, there really aren't a lot of tools. So for instance, we wrote a gen server that does that we put into what's it called, like a thread pool basically, or a process pool, and essentially like we send a we grab any one of these random servers. That one has a connection to a database and it goes and does the work. So you're kind of doing some of this stuff kind of by hand that maybe you get for free in some other language like PHP or Ruby or whatever. But it's really nice because then you can kind of see what's going on. So you get a little bit more visibility into what's happening. Moving along, I'm going to have to move pretty quick. Nearby, basically, we built this thing called a tag cache, which is essentially, if you think about it, we get this problem because the other data is very, very specific to sort of global. It's very global and it's very like hot. Like everything's happening in this little data set. The problem with nearby is everybody in the world has a different view of nearby. It's a little bit difficult to do that. So I created this sort of like fake city here. It's not actually Nashville, with sort of real Whisper data, and sort of imagine that you want to think about this as like a 3-dimensional graph search, but you don't actually want the things that are old. So the problem is like this is like a college campus in the background, and a lot of the activity is all in one place in these sort of really narrow but rural areas. So the problem with that is actually there's lots and lots of old data that you don't want. So what we want is we want like the things that are new, but if there aren't things that are new, we basically kind of want to sort, and we want to sort of increase the range in order to capture enough data to get a good data set for this query. And then we also want to sort of expand the time window so we can actually, well, we can't find anything, we might as well go get some old stuff. It's better than nothing, so we'll go and we'll find old ones. So we actually kind of wanted this thing where it doesn't actually work to do this just like using Lucene and doing like using Elasticsearch and doing like a nearby search. It doesn't work because it just gives you all of them. And it gives you like all of them. Yeah, you can sort by age, but you'll still actually get this giant data set for this very narrow area. But then if you have something that's not very close, you'll get nothing. So you end up having to do all these kind of weird queries. So how does Erlang help for that? So basically what we did, we came up with this idea of creating this tag cloud, where we tag using zip codes. In the US we use zip codes, and the rest of the world we use the geohashes. And we essentially, is everybody familiar with geohashes? They're like, it's really clever. It's like you take a latitude and longitude, and you turn to a base 32 number, and then it's like, I don't know if that's exactly what it is, but basically like, it's like a string of letters, right? And the cool thing is the more digits you have, the more it creates like a narrower bounding box around a particular area. If you want to get a bigger area, just chop a digit off the end and you get a slightly bigger box. So it's a very powerful tool for sort of like roughly figuring out where something is. It's not great for like, you know, dead on at a certain point, but we kind of don't really care about that. So we come up with these little geographic areas. We turn that into a list, in this case of zip codes. We tag those in the DB, and then we create a new whisper, and we store it in an ETS table. So now what we have is all these extra little ETS processes that are actually subscribing to new events. So a new event comes in and says, oh, I got a new whisper. Oh, great. That actually belongs to me because it's in my area. Store it in my queue here, or store it in my like sort of table. It's a GD set or something. Another data structure. And basically then I can sort of like keep these queues filled, right? So then when somebody comes in and says, hey, give me the nearby stuff, cool, okay, well, let's go figure out what are the tags near you. I'll go grab those tags, and I can go ask those actual Drum servers, send me your latest items, and it brings me this list. And if I need to, I can expand my area. So it's like really fast, and it's a little bit random, and actually kind of a feature in a way that we like. And so it really, really helps. So this is what that did to our load when we implemented that. It just totally solved a huge amount of problems. I think we got rid of like 3 databases that day. So that was pretty cool. So we went down from like, from 3 to 1. So anyway, long story short, Erlang's great for this kind of app. So last major area here, we've got this sort of moderation problem, right? So we have tons of content. That's a longer term problem that their team is working very hard to solve. In fact, there was an app called Post Secret, if you guys are familiar with Post Secret. Anybody familiar with that? It was a really, really big community, and they built an app, and the app actually just got obliterated by the sort of bad actors. They couldn't stop it with like 30 or 40 people. So, in fact, the day we started this project was the day that they shut down the app. And we were like, wow, okay, we cannot build an app that basically has the same problem. So we spent a lot of time thinking about that. So we thought a lot about sort of spam filtering. And we also thought about this idea that basically every single thing that goes into the app has been looked at by some human at some point. They actually approved it in a queue. So we said, but they're going to miss stuff. So we want to do some sort of remote wipe. So we wrote a classifier. We put it up on GitHub. It's basically just simple Bayesian filter. If you've read Paul Graham's essays on the plan for spam, it's based on that. It's also similar to the Ruby one, which is pretty well designed. But it's Erlang-y, right? We're also doing a bunch of heuristics like location of time of day, how many users this guy and whispers this guy created, probabilities. Like there's some things we're doing where we're saying, okay, this neighborhood, this area is full of sort of like bad content. Just ban the whole area for a week or something. There's some really interesting stuff. In fact, we do things like, hell banning. I love the concept. I explained this concept to my wife. She's like, oh my gosh, it's amazing. The idea that, you're like, I create some piece of content, and we say, great, thank you, and then we just let you think that it's there, and we throw it on the floor, right? So I noticed like Hacker News does that, and it's funny because people say, hey, dude, you're banned. Like, you realize no one can read your comments, right? Anyway, and so we do like remote delete. So remote delete essentially allows us to wipe content when it's already on the device. So we keep a socket open to our Erlang server. If you think about it, we're basically keeping a socket open because everything is HTTP except for this sort of back channel that allows us to say, hey, go delete this content even though it's already on your device. So for that, we basically need to register all these processes, right? So we use gproc, which somebody else already mentioned. Gproc's really cool. It does a couple of interesting things. It also allows you to do cross-process registration, cross-node. Sorry, not cross-process, cross-node. So you flip a certain setting, which is not easy to discover, and all of a sudden it starts to keep track of the process across all of your servers. And that's really, really powerful. It allows us to basically go in here, admin can say, hey, I want to delete this piece of content. Erlang looks up gproc, gproc goes, finds the right node, wherever it is, and then that actually deletes the, oops, that went the wrong way. There we go. And then that deletes it on the device. So it's very, very powerful and pretty efficient. There's some weirdness with gproc around multiple nodes where it's not good at adding new nodes later. So for instance, we want to add a new server with the system running. It doesn't actually work. But it's not that big of a deal. And with an app like this, every now and then, we take the servers down every now and then anyway. So if we build a new server, we'll just do a restart of the whole thing, and it's down for a few seconds, and it doesn't really matter, right? gproc, I'll just give a quick example of gproc. You can basically name processes, and there's a built-in Erlang function where you can name processes, but you can only use atoms. And Erlang has this really funny, hilariously bad thing where you can only create like a couple million atoms before the VM dies. So it's like if you create, has anybody heard of that? Anybody talk about that? Basically, it's a problem. So the nice thing about gproc is it doesn't use the atom pool. So the atoms don't get you don't get that counting against you. And if you have a couple million users, you can crash the server just by naming your processes. So you can also have these properties. I think Riak showed he used gproc in his demo for Cowboy. So anyway, I can register a process, and it's a horribly odd naming convention, but it says, hey, I want to name this, I have this N means name, G means global, I want to name it the user ID, which is the name of my user, which is like the device ID here, basically, something like that. And I can register it, and I want to basically put it in this gproc tool called client. And then I can essentially, I've registered this process name with this user. Now, if somebody comes in and I want to, send that user a message, I can say, okay, gproc send, and then I can basically pass in that event, and it gets sent to that user process. It's really cool for a couple of things. One is like we can tell people that are connected. So we're doing tons of push notifications where we're like, oh, don't push this guy. He's actually using the app right now. And that's really powerful. Like, it's really hard to do that in Ruby. Ruby or the other language, you can kind of figure ways around that, but it's just super powerful to say, okay, we're going to push to all these people, but not this guy. He's actually in the app. We can broadcast updates, and we can do the real-time deletes. So as I said, it has some issues. There's this thing that gproc uses called gen leader, which essentially selects a leader among all your nodes. If that node dies, it'll pick a new leader. It's some magical stuff. It's really amazing. But it's magic. So there are times it's like we thought maybe we should probably not use it, but it works, so it's great. Any questions on gproc or that kind of whole world of registry? Yeah?
What have you found causes nodes to die in that context?
Actually,
I don't often enough that you actually, oh well, it's just like the solar flare, it changes all the ones to zeros.
I would say in 8 months we've had one server spontaneously just stop responding, and then you couldn't even kill it in the Amazon console. So there's a relatively trivial chance of that. It's not that big of a deal. Usually it's just like some bug. I mean, it's like a coding error, and so it's like, yeah, honestly, not much, really. Yeah.
I just got a quick question about just clarification. When you started filtering the nearby searches according to zip code in the U.S., do you find the majority of your traffic to be from highly dense metropolitan areas in the United States?
I don't know. I mean, I don't know how much I can talk about that, but no, it's actually not.
Yeah. So you have more users in the middle of nowhere?
Yeah. Yeah.
Weird. Okay.
It's I think it's connected. If you look at the demographic, it's college students.
Yeah.
And college students in urban areas, they have stuff to do on the weekend. College students, college students in Tuscaloosa, Alabama. I don't know. No, I mean it's not true. I don't want to. I think it just that fits more the demographic.
Yeah.
Anyway, yeah, I don't want to have disdain for the users. I mean, it's a cool app, and it's like to the extent that Post Secret actually built this kind of amazing app, and I think that the goal is to have something similar, but something more commercially viable. I think I think it's really cool. I think it could be a really cool experience. It is. It's really interesting. So tools. So basically, there are a couple of things we use, and I'll finish up because I know I'm just about out of time here. these are a couple of things that I really like, and if you build a web app, or any app, I highly recommend these. Popcorn is one. The Tiger Text guys built. Tiger Text is kind of, we're connected to them a bit. We've done some, Inaka has done some work with Tiger Text, it's very cool. Basically, it's like Airbrake for if you're familiar in the Ruby world. It analyzes all your logs in real time, finds the ones that happen a lot, and then it pops them up on this great web UI. So the problem is when you get like a bunch of servers, it's hard to know if some random error really matters or not. But if you see it 573 times, it probably matters, right? Or you need to like get it out of the logs. So Popcorn is very, very cool. I should have put the GitHub link. Sorry. Boundary, as I mentioned, is TCP dump for the masses. Great UI. You have to run it on all your nodes, and you pay per hour. So, for us, we think it's worth the extra cost because it gives us some really cool visibility. I would say it's sort of maybe not necessary if I had a data center and I had some guy there, he'd actually just go and look at the network. But since we don't have that, it's really powerful. And then the last one that there was a lightning talk on, EPR, and I split these out, EPR, Redbug, and DTOP. So DTOP is like top for Erlang. You can run it on the console, it gives you your queue lengths, it gives you memory usage per process, incredible. Redbug's amazing, and the Redbug is a multi-node. So sort of final thoughts, I would not start with Riak again. It's not that I wouldn't recommend it, I just would say make sure you know when you want to use it. I probably wouldn't build our admin in Rails anymore because it's maybe a talk for another day. And I would probably do a lot more real-time metrics. We started using this thing called Vibrato, which is a really cool visual, it's like Ganglia, but it has some great support for Erlang, actually. And then, actually, we're working on this new app we just started called Kudzu, and it's connected to Redbug. You can get Redbugs if you're in the Kudzu. It's basically, it's terrible now, sorry, but basically, we're literally taking the Popcorn UI, and we're making it where I can run Redbug remotely. So I can just go in there and say, okay, I want to run a trace on any user that has this user ID across all the nodes and then send it back to me. Because one of the things we find is somebody who's like, something's wrong, my app's not working, and we can't tell because we've got like 10 or 15 machines to go like log in and like look at the logs. What's going on? Maybe it's a client bug, who knows? So our idea was basically we want to build like a web UI for Redbug. So anyway, long story short, Erlang's so many success stories with it. It feels like it keeps growing. It's not that hard to use. It's a competitive advantage to use it. All the things in here, I don't think about these problems. I don't have problems like I had in Java with cross-node communication, with sockets, whatever. It's just easy. So this is kind of a bad ending, I'm sorry, but my secret is Erlang. So anyway, so thanks for, if you have any questions, here you go.